We can calculate the x-intercepts, or I'm sorry, the intercepts of polynomial functions by looking for x-intercepts, which are points of the form x comma 0, meaning our y variable is equal to 0, x is not, and y-intercepts, which occur at points of the form 0 comma y, where our x variable is equal to 0. To find an intercept then, we want to set the opposite variable equal to 0 and solve for the remaining unknown. In example 12, to do that, we'll take each of the factors and set them equal to 0. So that means negative 3x is equal to 0, 5x minus 1 is equal to 0, and negative 4x plus 6 is equal to 0. To get x is equal to 0, x is equal to 1/5, and x is equal to negative 6 over negative 4, or 3/2. That means our x-intercepts will be 0 comma 0, 1/5 comma 0, and 3/2 comma 0. I can write that a little more clearly. 3 over 2. Then to find the y-intercepts, we'll set x equal to 0. And since we have negative 3 times 0, which becomes 0 multiplied by everything else, our function value will just be 0, so we end up with our y-intercept at 0, 0. Similarly, in example 13, we'll set each of those factors equal to 0, which will give us no solution when we consider negative 2 equal to 0. The second factor will give us x equals 1 as a solution, x equals negative 5/3, and x equals negative 1 as solutions. So our x-intercepts will be the point 1 comma 0, negative 5/3 comma 0, and negative 1 comma 0. And then to find our y-intercept, again, we'll evaluate this at 0, which will become 0, or negative 2 times the quantity 0 plus 2, times the quantity 0 plus 5, times the quantity 0 plus 4. In this case, not everything is being multiplied by 0, like we had in example 12, so we'll need to evaluate this. This will become negative 2 times 2 times 5 times 4, or negative 80, giving us a y-intercept at the point 0 comma negative 80.